There it goes. All right. This is lesson 12, writing and graphing systems. You may recognize this lesson if you were in my class last semester. We did do this right before the end of the semester. This is where we stopped. So, I want to undo that. Hold on. Do you notice anything else about these two lines? The y-intercepts? What are the y-intercepts?
The blue line is around 80.
So we could say 0, 80 for the blue line. What is it for the black line?
100?
Probably 100, yeah. So 0, 100 for the black line. That's approximate. I think it might be a little less than 80 for the blue line, and we can see that here. It's a little bit below there, but that's okay. What else do you notice here? What else do we notice? What does this point here mean? What does 3268 mean? What does that mean? Does what? It is where they cross. That is the intersection. What does it mean in terms of your x and y axis, what this information is down here? What's the x-axis? What's the label there? The number of oranges. So we can say the x value, so the 32. So we get 32 oranges. Okay. What about the 68? What's the 68? Okay, so we can have 32 oranges and 68 protein bars. How much will 32 oranges and 68 protein bars cost? Or how much money will they collect? This is in the text underneath the graph. How much money do they get? 304. So those two, or these, the oranges and the protein bars will give me, or give them, $304. Okay? What do you think an equation could be for the oranges and the protein bars? There are two equations we could make. What could one of them be? So I'm going to put the number in front of the letter. So you're going to say $1 times by the number of oranges. I'm going to change O to something else because O could be easily, what could that look like? What number? 0. So I want to keep it to where it looks a little different than the numbers that we write down, okay? So pick a different letter for oranges. S. 1S plus 4P, where S equals oranges and P equals protein bars. Can anybody see what my other equation could be? Continue to use the S and the P. There's one other equation we can get. We already used the $1 each, the $4 each, and the 304. What is left for me to use? The 100. What could my equation be with the 100? What does it mean whenever we have a total of 100 items? Everything's added together. And what are the things I'm selling? Okay, so we could say 100 equals S plus P. There are my two equations. Which equation represents the black line on the graph? Is it the black equation or the blue one? The black line up here represents one of these two equations. Is it going to be equation 1 or equation 2? Equation 2. And I totally didn't mean to do it in confusing colors and do a blue for equation 2. That one should be the black one. So if equation 2 is this line, that means equation 1 is this line. How can I verify that this equation matches this line? Do what?
Like the number next to the equal sign.
Mm-hmm.
The 304 and 100.
Yeah, we could plug in numbers and see, right? We could also solve for slope-intercept form. What is slope-intercept form?
Y equals MX plus
Okay. We're going to leave this at that because we're going to be matching these graphs down here to the situations. So we're going to go into more depth down here. We have these three graphs and we have these three situations. So we're going to match the graph to A, B, C, or D. So for A, we have a restaurant has a total of 20 tables, round tables that seat 2 people, and rectangular tables that seat 4 people. All 70 seats in the restaurant are occupied. So, what are my variables in this situation? So because it doesn't tell you the number of round tables or the number of rectangular tables, Those are going to be the ones we need to have variables for. So our round table, what letter do you want to give that?
R.
R. What do you want to give the rectangular table?
E.
What?
E.
E?
Yeah.
Okay. All right. So, how many total tables does the restaurant have? 20. What could my equation be for that? Yeah, 20 equals R plus E. All right. Which graph can I say definitely is not correct for this situation for A? What would the line look like for 20 equals R plus E? What would its X and Y intercept be? So if I plugged in, I'm going to move this over here. You don't have to do this part. If I plugged in R equals 0, we would get 20 equals 0 plus E. What does E equal? 20. If I plug in E equals, I'm going to change my colors there. If I plug in E equals 0, I will get 20 plus R equals, oh, not 20 plus R. I said that backwards. 20 equals R plus 0. What does R equal? Okay, so what are my X and Y intercepts? It's going to be, depending on which one we put as our X. Do you want R to be on the X-axis or E? E. So this one would be 20, comma, 0. And this one would be 0, comma, 20. So which line or which graph has a point on, or has a line that goes from 20, comma, 0, so coordinate 20, 0, to coordinate 0, 20. So they're going to be graph 1, 2, or 3. It's going to be graph 3. Which line, the black or the blue, goes from 20 to 20? The black one. So this line right here is 20 equals R plus E. Now I need to come up with the equation for the blue line, right? That's one we don't have yet. What information do I have here that will tell me how to get the blue line? $70 equals, so there's 70 seats in the restaurant. That's the total number of seats. Now what do I do?
2R.
2R, so because it can seat 2 people. 2R, what? Plus 4E. Okay. How can I verify that the blue line matches this equation? How about we solve for slope-intercept form here? So if I have 70 equals 2r plus 4e, do you want to solve for r or e? R. So we're going to solve for r. How do I isolate my r to get it to slope-intercept form? Minus 4e. Okay, so I will keep my 2r on the right. What do I do on the left? When I have 70 minus 4e, what am I going to get?
70 minus 4e.
70 minus 4e. Why can I not combine those? They're not alike terms. The 70 does not have an e, so I cannot combine terms if they both do not have the same variable or they both do not have any variable. What is my next step to solve for r? Divide by 2. What is 70 divided by 2? 35. What is negative 4e divided by 2? What's 4 divided by 2? 2. We keep our negative sign and we keep our e. Does my blue line cross either axis at 35?
Yeah.
Which axis? The x-axis. So that tells me that r, this number out or this letter out here, is my x value. So my x-axis or my x, yeah, we'll leave it, yeah. So that means round tables is depicted down here, or the number of round tables. I can't talk. Number of round tables. That means my y-axis is my number of rectangle tables. All right. I'm going to click over to this really quick. So it says to answer these two questions about every situation. On A, we already did the first part. So on A, X is round tables. And Y is rectangular tables. And for B, we're going to say, at what points do the graph intersect, and what do the coordinates mean in this situation? So my graph here, what is this point of intersection? What's the coordinate for it? 5:15. Okay. So our point is going to be 5:15. What do the coordinates mean? What does 5 mean? Round table. So 5 round tables. And 15 what? Rectangular tables. How many people will those two tables seat? Or those two types of tables? So the 5 round tables and the 15 rectangle tables, how many people will that quantity seat? 70 will seat 70 people. Does that make sense? Is everybody good? Anybody real confused at this point? Think we could do another one? Okay. Let's go back. Do you want to do B or C? Because I know you're probably running out of space on this. Nathan, pick B or C. D. B. Okay. A family buys a total of 32 tickets at a carnival. Ride tickets cost $150 each, and food tickets cost $325 each. The family pays a total of $90 for the tickets. So, what are our two variables here? What do we not know the quantity of? Which ones? Ride and food tickets. So for my ride tickets and my food tickets, I need to assign different variables. What do we want the ride tickets to be? R. What do we want the food tickets to be? F. All right. What is an equation I can make here from this information?
Equals F325 plus R150.
Okay, yes, that is one of them. So 90 equals 325F plus 1.5R. What is my other equation going to be? So we use the cost. We have one more thing we can use. What's left? Tyler, what's left?
What's left?
Mm-hmm. What's left in the information there?
0.20.
0.20. Mm-mm. Okay. Callie, do you know what's left?
I honestly get confused.
Okay. Do you know what's left? The 32. The 32 is the only number that is left that we have not used. So a total of 32 tickets at a carnival. So if that's the total, what do I do with the ride tickets and food tickets? You add them. So we take F plus T, or not T, R, I don't know why I said T, equals 32. Can I tell from these two equations which graph represents situation B? The second one. How'd you get the second one? The black line goes to 32 on both axes. So that tells me that is F plus R equals 32. Because if we plugged in a 0 for F or R, the other variable would be 32. So my line needs to go from 32 to 32 between the X and Y axis. Okay? So how do I verify that that blue line is the equation for my red equation? So the red equation is the equation for the blue line. How do I verify that? How about we just plug in a point on this one? So pick a point that is on the blue line. How about we do trying to find a good one. I think this one could probably be on the line, so let's do 525. So if we plug in 525, we don't honestly know which variable is which, so we may have to plug it in twice. So we can say 90 equals 325. I'm going to guess that I can do less food tickets. So I'm going to say 5 plus 1.5 times 25. That is just my assumption. So, what is 325 times 5? 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. Then 3 times 5 is 15 plus 1 is 16. So 90 equals 1625 plus, I'm going to erase this over here. Then we are going to do, let's do 25 times 1.5. We're going to get 25. 5 times 10 is, 5 times 2 is 10, plus 2 is 12. Okay, so 3750. That does not work out. I did do that math right, correct? Let's flip those numbers because that was not enough money. Because that would not work out. So 325 times 25 plus 1.5 times 5. So 325 times 25. I'm going to do this real quickly. So 71.25, and then 1.5 times 5 is going to be I think that is close enough to what we need it to be because we're going to get 80. No, we're going to get 78.75. So that means that line is slightly above that line. So our x-axis is our F. No, our x-axis is our R. because the 1.5 was times by the 5. So our x-axis is the ride tickets. And our y-axis is the food tickets. So on the next page, we're going to write for B. X is ride tickets. And Y is food tickets. And then they intersect here at roughly probably 7 or 8, and we need it to be to where they will add together to get 32, so we need either 24 and 25, one of those two. Okay, so what do these coordinates mean? Approximately. This is an approximate coordinate because it's not on the line. It's not on the line, so it's not going to be exact. And honestly, we can probably say it's not 25. So let's go with the 824. What does the 8 mean? Which was the X value? Food or ride tickets? The ride tickets. And 24 was what's the Y? Food tickets. How much would it cost for those? What did it tell me in the information? Was it 90? Yeah. It will cost $90. Okay. Let's see here. I think we're going to stop here for today. Make sure you work on the practice problems on Canvas, and I will see you in class.